Hey guys, I want to talk about forces in the atomic world. Vanderwalt Forces. There are three main Vanderwalt forces, and these are usually covalent, right? So these happen to be in the covalent bond. So the three of them are London forces, dipole, and hydrogen. So let's start with London forces here, right? So let's say if there's a let's say if there's a neon atom here. Let's say it has 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. So we know that there's some probability that the neon's atom, the neon electrons are gonna there's some probability that all these neon electrons are gonna go to these orbitals here. So let's say there's 8, let's say it becomes 9 or 10. So when that happens, this is gonna be partially positive and this is gonna be partially negative. So this polarity between very minor polarity, we can't say this is polar. The very minor polarity causes some attraction, right? And it's instantaneous. And this is called London forces, right? The second one is called dipole. So what dipole is basically it's the same as the first one, but at a bigger scale. So let's say for an example, like let's say H2O, right? So H2O is also H, right? So what happens is that this is also a the O is O is very highly electronegative, and H has low electronegativity, right? So since it has low electronegativity, oxygen is going to have most of the electrons, right? So 2 4 6 8. So oxygen is going to have most of the electrons, causing it to be partially positive, partially negative, and hydrogen to be partially positive. And this creates a polarity between these two different atoms, creating attraction, right? So this is dipole. The third one is called hydrogen bond. And this, from the word hydrogen, we can see that it happens with hydrogen, and it happens with the three most electronegative elements: fluorine, oxygen, and nitrogen. So what happens is that since we know that hydrogen has one proton, one electron, right? So what happens is that fluorine, let's take an example of fluorine, has high electronegativity. So when it has high electronegativity, it wants electrons. So what it does is that it takes electrons from hydrogen, exposing hydrogen and revealing, and hydrogen reveals its proton. When hydrogen reveals its proton, what happens is that there's a high polarity, right? There's a high polarity between the hydrogen proton, and fluorine electrons, creating high attraction. So this is hydrogen bond is also same with hydrogen oxygen, since it's one of these FON elements, right? So these are the relationships. We know that London forces is the weakest, and we have dipole, and then we have hydrogen bond. These things will affect many other characteristics like boiling point, viscosity, melting point, etc. So those were the Vanderwalt forces. The forces important in the atomic scale. Thank you.